In the section on applications of linear functions in college algebra, you will be required to write equations of parallel and perpendicular lines. Parallel lines are two lines that never intersect one another. And what you will learn is that they have the same slopes. So first of all, there are two lines that never intersect. And they have the same slope. You probably can just deduct that they have to have the same slope, right? If one slope is different, then the lines will eventually cross one another. The way I like to think about this, we've talked about slope before as rate of change. So think about driving down the highway. And if two cars are driving at the same speed, right, they have the same rate of change, they're going to always be really parallel to each other. One's not going to advance and go above or below the other one, so they will never intersect each other. Perpendicular lines are lines that intersect at right angles. If you recall, a right angle is a 90-degree angle. So these are two lines that would form a right angle at their intersection. Now, their slopes, again, this will be something you'll discuss more of in the college algebra content, but their slopes are negative reciprocals of each other. So first off, that means that they have to be opposite signs. And we can kind of tell here, if one line has a positive slope, which is increasing from left to right, for it to intersect at a right angle, the other one has to be decreasing from left to right. So they have to be opposites of one another. And then their reciprocal part is that the rise or run is interchanged. So the change in y over change in x is flipped over for the line that's perpendicular to that. And again, more information will be in the college algebra content, but the whole premise of this is for you to be able to understand reciprocals, opposites, and equivalent values. That's going to be very key to being able to understand what the slope of a parallel or perpendicular line might be. And so let's just recall a few things. If we have the number a, then the opposite of that number is denoted by the opposite of a. In other words, if 5 is our number, the opposite of 5 is going to be denoted as negative 5. If our number is 1/2, the opposite of 1/2 is negative 1/2. The reciprocal of a number, let's say our number in fractional form is a divided by b. Then the reciprocal is just simply b divided by a, right? We invert the fraction. So if our number is 5, remember 5 is really 5 divided by 1, its reciprocal is 1/5. If the number is 1/2, the reciprocal is 2 divided by 1, or just simply 2. If our number is negative 3/2, the reciprocal is negative 2/3. So simply taking the reciprocal does not change the sign of the number. It simply inverts the numerator and denominator within that fraction. Now the negative reciprocal, so if our value is a divided by b, the negative reciprocal is going to be the opposite of b divided by a. So for instance, the negative reciprocal of 5 divided by 1 would be a negative 1/5. So we change the sign and invert the fraction. The negative reciprocal of 1/2 would be a negative 2 divided by 1, or negative 2. The negative reciprocal of negative 3/2 would be a positive 2/3. Now equivalent numbers, if we have a number a divided by b, a number is equivalent if we can multiply the numerator and denominator by the same value. So like a times c divided by b times c would be an equivalent value. For instance, 1/5 has an equivalent value to 2/10, -3 over -15. The number 5 has an equivalent value to 5 divided by 1, -25 divided by -5, right? Lots of equivalent values for numbers. Now we want to apply these to some problems. In example 2, we have to find the slope of each line and state if the slopes are the same or equivalent values, opposites, reciprocals of each other, or negative reciprocals of one another, or possibly none of those. We are given two lines, x plus 5y equals 10 and 5x minus y equals -5. We want to determine how their slopes relate. Recall that to find the slope of a line, we need to write the equation in the form y equals mx plus b. So x plus 5y equals 10. We're going to solve that equation for y by first subtracting x from each side to get 5y equals -x plus 10. Then we need to divide each side by 5, and that's equivalent to dividing each term by 5. So -x divided by 5 is -1/5 x. 10 divided by 5 is a +2. The slope of this line is a coefficient of x, which is -1/5. In the equation 5x minus y equals -5, we solve for y by first subtracting the 5x. That gives us a -y equals -5x minus 5. To solve for y, we divide each side by -1, which is equivalent to dividing each term by -1. This in turn changes each sign. We get y equals 5x plus 5. The slope of this line is a coefficient of x, which is 5. Now our goal is to determine how do these slopes of -1/5 and 5 relate. They are negative reciprocals. In part B, we have y equals -2x plus 6 and 4x plus 8y equals 16. The first equation is already solved for y, so the slope is simply -2. In the second equation, we have to isolate the 8y first by subtracting 4x. That gives us 8y equals -4x plus 16. Now we divide each side by 8 to get y equals -4/8. When we simplify that fraction, that's -1/2 x. Then plus 16 divided by 8 is 2. The slope of this second equation is -1/2. How do -2 and -1/2 relate? They are the same sign, so they can't be negative reciprocals. They are just simply reciprocals. The last one is x equals negative 3 and y equals 4. X equals negative 3, if you recall, that is a vertical line. Always x equals a number is the equation of a vertical line. Y equals a number is a horizontal line. The slope of a vertical line is undefined. There is no run in a vertical line, so you would be dividing by 0, which is undefined. In a horizontal line, the slope is understood to be 0. In fact, y equals 4 is really the same thing as y equals 0x plus 4. So the slope is 0. These are really just special cases that we would have to know when it comes time to determine how they relate. A vertical line and a horizontal line are actually perpendicular to each other. So though we can't really say explicitly how their slopes are relating, the lines themselves are perpendicular. So that will come up later on. So we'll have to say here that the slopes are neither or none of these. I can't remember what I said on the problem, but they're really not the same. They're not opposite. They're not reciprocals, and they're not negative reciprocals of one another.